But it's something like was that.
No,
Yeah.
but I think it's also because, in my opinion, they cut it to like, you did that 2 minutes. Yeah, exactly.
Another folding field.
Of course.
Well, it's
So should we kick this thing off? I think we're ready, right? Or is there some more people coming in? Right. Good. Yes. There you go. Mine, this is over here.
Oh, they will.
Oh, lighting lights. Yeah, it is, yeah, it works, the light works.
My name is Dan Durkin. I am the president of the San Francisco Amateur Astronomers, the SFAA. Oh, thank you, thank you, thank you. Thank you. How many of you are members? Show the hands. Okay, wonderful. That's great. Thanks for coming out tonight. If you're not a member and you want to find out more, you can just Google SFAA. Ignore the first hit, which is going to be the San Francisco Apartment Association, and go down to the SFAA Astronomy Association. There's lots of information there of what we do and the events that we have. There's an event calendar. There are special events that aren't listed on that calendar. Unless you're a member and log in, you'll see the special member events there. Things like our Mount Tam Star Party. And I think Jason had some wonderful slides going through what's coming up in our future here in the club. Couple of items to mention to you. One is October 5th. Hopefully members received an email about the Mount Tam Science Quest events that are happening that day and night, including an SFAA enabled star party for the public. You all had early registration. It's now open to everyone, so please, now's your chance to sign up. They're very popular and will likely fill up. The other thing is, if you're interested in becoming more involved in the club, please talk to one of the board members. And we have Thunmai down here with the computer. We have Jason as a board member, and Raj and Tina outside are board members. There they are. Oh, they're inside now. They're everywhere. Any other board members? I don't think so, but talk to us. And if you have ideas of things you want the club to do, please talk to us. We are also preparing to do our elections for next year for officers. And if you'd like to get more involved, feel free to talk to us. We have space for you. With that, I'd like to introduce our speaker. Is that fine? Yeah, so our Jason, I owe a lot of gratitude to. Jason restarted this lecture series this year. He is our chair of the speaker committee chair. And I'm happy to announce that next year we'll be going to every month having a lecture here at the Randall Museum. Thank you for that work. And Jason is a senior hardware engineer at Apple. And about all I can say about that is he does something with cameras. And that's all.
I wasn't actually, that's all right.
Oh, you were going to say?
I work for an undisclosed tech company in the Bay Area.
Oh, okay, that's not where your LinkedIn. I said too much already. You might want to clean up your LinkedIn. But Jason is an avid imager. He's involved. He is often at our start parties. He has a very cool set that are you going to talk about tonight? The zooming in of the
In peripheral, yes.
peripherate. Okay, he has this multi-camera system that will allow you to zoom into an object, handing off from one camera to the other, which is very cool. So with that, I'd like to welcome and thank Jason, and the show begins.
Yes,
There you go. Thank you.
Thank you. You're welcome. Okay. Yeah, you got the preview already. So thank you. So tonight's AV setup was a demonstration of what astrophotography is like. If any of you have done it, you know that occasionally things don't always work right out of the box. So thank you for your patience. Thank you, Thunmai, for for setting this all up. I'm really glad it's working. So, yeah, normally I'm the one introducing the speakers. Tonight, I volunteered to be the speaker. And I want to start with a confession, actually. And the confession is, well, as you can see, I am an astroholic. This is not something that I ever really planned for. I never thought it would happen to me. My own story, it really goes back probably a little over 20 years. I was hired at the Anglo-Australian Observatory, and honestly knew nothing about astronomy at the time. They hired me as an engineer. Unfortunately, very quickly, as you can see, I fell into the wrong crowd, and things just went south from there. While there, they trained me in camera electronics. Then they proceeded to train me in image sensor characterization. And what can I say? I was hooked. Who wouldn't have been? I eventually, a few years later, I moved back to the U.S. Tried to come clean, start a new life, try to start over. But my addiction followed. Before I knew it, I was buying telescopes, cameras. I even built my own camera from the ground up just to expand on some of these ideas that I had seen at the observatory. Even to this day, I have this constant craving. And if I were to describe that craving, it would be very simply, I want to see more. I'm going to say it one more time, I want to see more. Let me give you a demonstration of what I mean. If I were to go outside tonight here in San Francisco and look up, actually,
Yeah, let's
do
dim
we
the
have
lights.
a room light control here? It may be someone at the front desk. Kip, thank you.
That's what the Milky Way really
Well, you're not far off, yes. If I were to go outside tonight and look up at the night sky, I would see stars. This doesn't really do it justice, but as you can see, the light pollution is affecting our view. It is limiting our view. And when I look up at the night sky here in rural areas, and when I do, and again, I do apologize, we are the room lights. I'm going to just, let me pause for a minute because this is going to be very limiting under these lighting conditions.
there.
Okay, so if we were going to go far away from the city lights, the sky gets darker, the stars appear brighter, and you can start to see the Milky Way, and it's really quite beautiful. And when I have done that, I still am left with the desire, I want to see more. I wish,
Wow.
that my eyes, thank you. I wish my eyes could be 100 times more sensitive than they are in real life. If they were, well then the Milky Way would truly come alive in full color. I would be able to see nebula and more stars than I could imagine. If I could, honestly, I would still want to see more. That would not be enough. I would want to have tuned vision that is selective, that I can just tune in on the exact wavelengths associated, for example, with hydrogen, sulfur, oxygen. These elements that are directly tied with the birth and death of stars. If I had that kind of vision, the universe would take on a completely different light. The nebula that is the birthplace of so many stars would just stand out gloriously. It would be incredible. If I had that kind of vision, I would not be satisfied still. I'd want to see more. I would want to get closer and closer to the action. Past the Lagoon Nebula, past the Omega Nebula on the bottom, into the heart of the Eagle Nebula. I would want to get so close that I could actually see the talons of the Eagle Nebula, the talons of the eagle, those famed pillars of creation. If I could see all that, would I finally be satisfied? Well, no, because this is only the beginning. There are so many other places in the universe to explore. So if you can understand my constant craving, then what I will say is photography just may be the solution you are looking for. There are different kinds of photography. Let's start with everyday conventional photography. This is like 99% of all the pictures we ever take. And I'm going to state this, it's going to seem obvious, but it's important. The goal of everyday photography is to capture what we saw. It's really that simple. So the camera should emulate the human eye in some way. It should have a similar response. And the result is that we're preserving a memory. We are capturing something that we can show others and say, this is where I was, this is what I saw. Contrast that to scientific imaging, where the goal is not to capture what we saw, but rather to reveal what we cannot see. This example here is a thermal image, and it's just one example of the many types of scientific imaging. And the camera, it's so important, the camera has capabilities beyond what the human eye can see. So the result is this captures our curiosity. When I look at a scientific image, I look at it and say, why is the roof of my deck so hot? Is the sky really that cold? It invokes questions. And that is the purpose of scientific imaging. Now, right in the middle, very conveniently places astrophotography. Where does this fit in? Well, the truth is it draws from both categories. And it's really at the discretion of the photographer. There are going to be times where it is best to try to capture what we saw or what we would see if only our eyes were sensitive enough. But then there's other times where that simply doesn't make sense because we are either looking at colors that the eye cannot see or we are looking at color separations that our eyes cannot perceive. And in that case, the photographer may decide to shift colors around in order to enhance what is there. There's a quote, I really appreciate this quote. The goal is to use color to emphasize structure in an aesthetically pleasing manner. Our hobby is very technical, but the end result is art, technical art. The reason I love this quote is because it shows how astrophotography ties in both the scientific and the creative. It ties together the technical skills as well as the artistic. And the question next would be, can you think of any other examples in our daily life that do that bring together these opposite sides of our brain in order to accomplish something but make it enjoyable in the process? There are many examples, but the one that I'm really thinking of today is baking, is cooking. Right here, this is images from earlier this year. My wife and I were in a baking competition put on by KQED, the radio station. And the goal was to bake a cake in the shape of a supernova, of an exploded star. So I started with one of my images of the Crab Nebula, a well-known supernova, and this is our cake on the right. Took a few attempts to get it right. There's always experimentation involved, but we had fun doing it. Baking and astrophotography both combine our technical and creative skills. They're similar in other ways too. In my opinion, both can be a little bit intimidating when you're first starting out. If you've never done either and someone just puts you in the kitchen or in front of a camera and a telescope, you'd be like, where do I start? And that's where recipes come in. Recipes help hold your hand just enough, give you a little bit of instruction so that you are free to experiment. And that is why I present to you today, that was all the introduction, present to you Baking with the Stars, recipes for getting started in astrophotography. So when I was growing up, my mom had a recipe box. It looked something like this, and if you opened it up, you'd find it was full of index cards with handwritten recipes in various categories. There's a category for breads, another for desserts. I don't remember any other categories other than those two, but we're going to use this as a model for our astrophotography recipes. And like Mom, we're going to try to be a little bit organized. I'm going to put, referring to the target, the thing that we are photographing, big things on the left, small things on the right. We'll go a step further. We're also going to put bright things on the bottom, dim things on top. And as you can see, we just might have 4 categories: big and bright, small and dim, big and dim. Remember, this is referring to the astrophotography target and not the photographer. But the other point to mention here is, besides just because we want to be organized and put things in categories, this is actually giving insight into how to take a successful photo. You see, if something is large, you don't even need a telescope. A wide angle or telephoto lens will do just fine. If it's small, you need a telescope. If something is bright, just take a snapshot. Whereas if it's dim, you need a long exposure in order to get it to turn out. So this is already giving insight into what we need to take that photo. So here we are, 4 categories, 4 types of astrophotography and 4 recipes. First one we're going to look at comes from the big and dim category, and that is the category of nightscapes. The specific recipe we're going to look at is Milky Way a la mode. Now, if you've had pie a la mode, you know that's pie with a side of ice cream. Here, it's the important part of this photograph is we are capturing the Milky Way, but we're also incorporating the foreground. We're anchoring this into our real world experience. The ingredients list is actually quite simple. You need a camera, a tripod, and a wide angle lens. It's really quite that easy. And the instructions, 30-second exposure. We need a slightly longer exposure because the Milky Way is dim. Under a very dark sky for the exact same reason. If the sky is too bright, you're not going to see it. What I really appreciate about Milky Way photos, Milky Way a la mode as this example, is they're personal. I've taken many astrophotos, and at times I will look at it years later, and where was I when I took this picture? I don't know. But I do know where I was when I took this picture. My wife and I, about 9 years ago, were newly dating at the time, and we were camping out near Yosemite, and I went out one night with the camera and a tripod, and I set it up, got this image right there at the campground. So this right here is anchored to a memory to me. This is tied to a personal experience. In fact, I would argue that of all the types of astrophotography, this one has the most bang for the buck. This is a great starting point. You don't need to worry about tracking issues. You don't need to worry about computer talking to the telescope, to the mount, to the... It's as close to point and shoot as you're going to get. It's personal, opportunities for creativity. You can fit everything you need in a backpack. You can set it up in a minute. Nightscapes, the Milky Way a la mode is a wonderful place to start astrophotography. Here's another example. We were staying up at Sea Ranch, and I went down to the beach one night. In this particular photo, I brought a flashlight with me, and I used a flashlight to light paint the beach, the water, and the rocks in the foreground, just to give it a little bit more character. Here's another example. I accidentally did a little bit of spectroscopy. You see, we were staying at a ranch in Colorado, and the ranch had 2 outdoor lights. Honestly, I don't know for sure what kind of lights they are. I'm just going to take a guess here that one of them was sodium vapor, which is why some of the trees show up very yellow. And another one is probably mercury vapor, which is why the trees turn up very green. Now, by eye, I couldn't see this. My color acuity goes way down, as does any lens at night. But the camera can see it. Here we go. Oh. Okay. Technical difficulty. I guess I'm going to skip this. This was an animation. This is a time lapse of the Milky Way going across the sky, but the video does not want to play. Oh, there it is. Good. And finally, I really love this photo. This is not one of mine. I attended a advanced imaging conference a couple of years ago, and one of the speakers at this conference was Carrie Ann Hepburn. You can follow her on Instagram, Weather and Sky. She gave me permission to use this photo, and I was so glad to be able to use it because it is a wonderful example of how far you can take this art to be truly creative by composing the foreground, spending the time to master the background, to get your tones correct, to get the colors right. This really shows the blending of the technical skills as well as the creative. And that's a wrap on one of our 4 recipes. We have now covered nightscapes. Our next category is going to be from the big and bright category. So let me ask, I can't really see hands that well, so tell me, in the night sky, what is big and bright? You got it. So we're going to look at lunar photography. The recipe, Mon Appetit. The recipe is really not that much more complicated. We still need a camera, we've already got it. Still need a tripod or a mount, depending on how large your lens/telescope is. And then we need a lens or telescope. The difference being A telephoto lens will give you a wide shot view of the moon, but with the telescope you can get in close. Now, this is in the bright category. We don't need long exposures. If you try a long exposure on the moon, you'll saturate your sensor. So the exact exposure depends on your camera and pixel size and a bunch of other parameters we're not going to get into, but a millisecond is a really good place to start. And that's really it, no further instruction. The moon is photogenic, it's there, it's waiting to be photographed. Just set up your camera on the telescope, point and shoot. And you get the moon at night, moon during the day. I've seen images of the moon with the International Space Station traversing over the front of it. It's really enjoyable to photograph the moon. Now, I can't speak for you, I'm only speaking for myself. Occasionally, I like a challenge. And when it comes to the moon, sometimes I want to let's just call it moon appetit for special occasions. You know, having that special guest over you really want to impress. So I have seen, the goal here is to photograph the moon so that it is interacting with the foreground. I've seen images of the moon resting on a basketball hoop. I've seen images of the moon being loaded into the back of somebody's SUV. What I'm trying to do here, you can see the camera is set up on a tripod with a small telescope on it. I'm aimed at Coit Tower here in the city. And I'm waiting for the moon to be positioned so that it is resting, balancing on top of Coit Tower. Now, seems simple enough. I gotta be honest, I've tried this many times and succeeded only a few. There are many things that can go wrong. First tip I want to give is wait until the moon is at an elevation of at least 2 degrees above the horizon. In this particular photo, my goal was to get a photo of the moon balancing right on the point of the Transamerica Pyramid. I couldn't even see the moon until it was up at this level. The first couple degrees of atmosphere are just, it's like imaging through milk. So you really have to wait till the moon is a couple degrees up. You should also pick a target that is at least 300 meters away. Now, the exact distance is going to really depend on your telescope and camera and F number and so on. But you can see here, I'm taking a picture of the moon with the San Francisco City Hall in the foreground, but it's blurry. It's a nice photo, but it's blurry. And if you want both to be in focus, you need to pick a target that is far away, or go down to a very small, or high, rather, F number. Next tip is, there, okay, refresh. Wait for, be within 30 minutes of sunset, especially for the full moon. In this particular photo, I was well after that, it's night. And even though I like the photo, the moon is so bright compared to everything else, I wasn't able to adjust the light curves in order to get the tower to show up. And the last tip I'm going to give is be precise. I have gone out doing photography by looking at Google Maps and, oh, the moon is going to rise in the south by southeast. I'll just aim in that direction. It's never close enough. The moon is only ½ degree across, so you need to be precise with your angle that you're looking at, not only in the compass direction, but also in the what's called in the elevation. In both of those angles, you're playing a three-dimensional puzzle here of trying to get both angles to line up at the right time at exactly the right place. And the best way to do that is use an app that will help you with this alignment. I happen to be using PhotoPills. There are many others that you can find. So if you've done all that, and you have a little bit of luck on your side, you just might get the photo that you've been trying to get. And in this case, I succeeded. I got a photo of a giant PlayStation remote. So now you can't unsee that, can you? So that's the second category. I'm going to be very brief on this third category. This category is the small and bright. That happens to be planetary. And the recipe is the planetary petit fours. If you're familiar with petit fours, these are the exquisite, tiny little French desserts. They're intricately decorated, they're packed full of flavor, and in my opinion, they are just big enough to make you mad. The planets are beautiful, but they're surprisingly small and very difficult to get good images of. These are not my images. Credit to Scott, who gave me permission to use his photos. This is not my area of expertise. I've not been able to get this kind of resolution. I know enough of the basic ingredients that you need. You're going to need a long focal length telescope, and you're going to want a tracking mount. That is a mount that follows the planets, because otherwise they move, you're zoomed in so far, they move out of your field of view too quickly. I know that you'll need a short exposure. You'll probably need many of them, because you're going to probably take 100 photos to try to get the one that's crisp. Precise focus, of course. Excellent seeing. I'm going to demonstrate what I mean by seeing, because it's a concept that's not always familiar to people. So here's one of my images. I was pretty proud of this image, honestly. I was zoomed in far enough to the moon where I had pretty good definition on the craters. And there's Mars right above it. But notice that Mars, even though I'm zoomed in this far, Mars is still just a dot. I wasn't able to get any resolution on Mars. Now, I'm going to play this. It's an animation. You're going to see that the Mars comes very close, apparently very close to the moon. I think that's cool. But the other thing to look at is it will appear that I'm imaging through shaking jello. And this is atmospheric turbulence. Now, you could imagine, and any one of these snapshots, there are certain portions of this frame that happen to be in really good focus while the others are moving. And you just have to play this game of luck with astrophotography of planets to try to get that one shot where things are really good and crisp. And the reason this is there are always air currents in the air, hot and cold mixing together. It is very prominent if you're ever in a parking lot on a hot day and you look across and you see the cars on the other side are just rippling. And that's because the air currents are distorting our vision. When you zoom in as far as you can with the telescope, it magnifies those air currents, and part of the art of planetary photography is waiting for those conditions or going to those conditions where you get really excellent seeing. You have minimum distortion. So my takeaway from planetary photography, although it is easy to do, it's very hard to do well. And I have great respect for the people who do it well. Okay, 3 down, 1 to go. The reason I'm going somewhat quickly here is, number one, the fourth one is arguably the most complicated, but also because there is a little bit of an after-dinner show. That is, after we get through these 4 recipes, we're going to have a slideshow that is a compilation of all the work that others in the SFAA have done. All right. So, last category is from the big and dim category, none other than deep space. Deep space is a whole category that covers nebula, galaxies, and other faint objects. And the one we're going to pick on is a well-known nebula, the Orion Nebula. The recipe is the Orion sundae. Now, I love ice cream sundaes. This is going to be a great recipe. Unfortunately, this is a base only, no toppings. And you're thinking, what fun is an ice cream sundae with no toppings? Well, it's still ice cream, so that's a good start. But the reason I'm doing this is I'm starting with the very basic image, and we're going to improve it from there. So at the very most basic, you're going to need a camera and a telescope and a tracking mount. This so far is seemingly simple, and you might have thought that deep space photography was very hard. We're going to set the exposure time for 100 seconds, and you will get something like this. Honestly, you may get a better image than this. I actually accentuated the errors in this image to make it easier to talk through. So the goal now is to figure out what toppings we might want on our Orion sundae in order to make this a truly beautiful image. Those toppings are going to come in 3 general categories. We've got equipment, including telescopes and cameras and filters and so on. We have methods, that is your camera settings, the environment you take the photo in, and other parameters that you set during the acquisition. And then you have processing. There's a whole art to be done after you get the images, and you need to combine them and work on tone mapping and light curves and color balancing, etc. So these are the 3 categories. Now, show of hands, how many of you have done deep space photography before? Okay, I can see at least 4 or 5. It is dark in here. I might ask you to shout out answers as we go along. I would love for this section to be interactive. So the first thing I don't like about this image, look at the stars on the outside. They're all doing kind of a circle dance. I thought I was doing well here because I thought I had a tracking mount, but for some reason stars are still going around in circles. So does anybody know why we have this circle thing going on? Well, it's not back focus in this case. Back focus definitely would make some of the outer stars bloom in different ways. But in this case, it's because what we have here is field rotation. That is, think of an inexpensive telescope mount as being like an R2-D2. It pivots up and down, it pivots left and right. So you can follow a star going through the night sky, but the problem is the stars do not march through the sky in that way. The stars actually arc in a circular fashion through the night sky. And an inexpensive mount, the cheaper, the compact, the lighter mounts, don't do that. They only follow the center of the target. They don't follow the arcing motion. So if I would have gotten a more expensive equatorial mount, it would have rotated my camera with the stars and I wouldn't see this effect. There's another way to fix this. It's not just with hardware. This is in magenta because it's a combination of both method and processing. Instead of doing one long 100-second exposure, I could have done 10 seconds exposure. I still would have gotten a little bit of arcing on the outside, but it would have been reduced to the point where I might not notice it. Of course, now I've got a processing job because now I have to rotate all these images and add them together in order to get them to line up. But the point is there are multiple ways to fix this problem. Another problem, light pollution. This was taken in the city. Can anyone shout out, is there an equipment method that helps limit light pollution? Well, you know, a faster telescope will bring in more light both from the city and from the nebula. Filters. Filters are definitely a good hardware solution, yes. Is there a method? Is there a way in which to limit light pollution? Yes, absolutely. Go to a dark place. Now, what about processing? Can you get rid of light pollution through processing? Yeah, it's a method called gradient removal, basically. You know, something is in a very basic form. You can even do it on your phone, your photo app on your phone. It's called black level subtraction. There are more advanced ways of doing it, but basically it's just subtracting a gradient from the image to enhance the what's in the foreground more. So we have options. Image noise, here getting a faster, wider telescope will actually definitely help with noise because it brings in more light. Method, we could just take many more exposures and of course add them all together. And in processing, there are many denoising algorithms that will help limit the noise. What do we do about saturation? Oops, I just gave away the answer. So much for that. We'll have to quiz you next time. The middle of this image is completely bloomed out. It's saturated. I could have fixed that with a high dynamic range camera. I could have fixed that by taking a combination of short and long exposures, or I could go into Photoshop, for example, afterwards and adjust my light curves to accentuate the lows and to attenuate the highs. Here's a fun one. Have you, this is not a technical term, star squiggles. Have any of you run into this? Where you have your mount tracking, you think everything is going well, but your stars just do a figure 8 on you? Has that happened to you? It's definitely happened to me. I spent a lot of time trying to figure this out. I started by cleaning all the bearings in my mount. That wasn't it. I then went and I checked all the power supplies, made sure my power supplies were stable and not being loaded on me. That wasn't it. I eventually attached a laser pointer to my telescope and set it up inside the house and had paper taped all over the wall with data points as it was going along so I could figure out the source of this error. There's a saying that 2 weeks in the lab will save you a half hour in the library every time. Well, the source of this problem happened to be in the last place I looked, and that was the owner's manual for my telescope. This is a well-known issue, and that is the simple fact that every motorized telescope uses gears. And gears are never perfect. They always have a little bit of wobble. Even though they try to make them well, they're never perfect. And every time that gear turns, you have a little bit of error. So how do you fix that? How do you get rid of these star squiggles? Is there a equipment way to do it? Say what? A balance? Backlash, yes. That will definitely help. That's one of the settings that you can do to help with this. Another one that's common is what's called a guide scope, which means basically you're going to get a second camera and a second telescope, probably smaller, and mount it to your main one, run those images coming out at a fast rate into your computer, and then run the computer control into your mount to give it corrections. Now, this may sound complicated. This is a well-known, tried and true method, and software and methods exist for this. You don't have to invent it, but it does add a layer of complication. Now, you can also, if you don't want to go the hardware method, you could go the method plus processing. That is, you could take a bunch of short exposures and then realign the images after the fact. Last one here, hot pixels. Your camera, when it does long exposures, the pixels are collecting what appears to be light, even if there's no light present. Usually it's at a very low level on average, but there's always a few oddballs, maybe 1 in 1,000, but that's all it takes when you have all this salt and pepper speckle all over your image of these bright pixels that are just sucking up, not sucking up light, but rather making it appear as if there is light there. You can fix it with a cooled camera, that's going to minimize it. You can somewhat fix it with dark frames, that is, take a bunch of frames in the dark and subtract that from your illuminated frames. This doesn't always work. Hot pixels are a little bit like a bad hair day, in that you can have 5 bad hair days in a row, finally you go into the hairdresser and your hair is perfect. Hot pixels are the same way, they're not stable. Sometimes they're there, sometimes they're not. So they are very elusive. So if I were in the audience and I had never started astrophotography, I would look at this chart and go, oh my gosh, this is overwhelming, there's no way I can do all this. But let me ask you, if you walked into the ice cream shop and you saw all 80 toppings there on the wall for you to choose from, would you feel overwhelmed? No, it's opportunity. Not everybody does it the same way. There are some people who put great emphasis in their equipment. I have a 18-inch telescope with double polished optics, low, and so on with the best camera. There are others who put more into the method and say, I focus on this object for 58 hours and I have the best image. But then there are others who are saying, you know what, I'm using mediocre equipment on a shoestring budget from my backyard in the city, but I've mastered processing such that you can't even tell. So basically, nobody puts all the toppings. That might not be true. Most people don't put all the toppings on their sundae. They usually choose a theme, and it's no different in astrophotography. It is up to you to kind of choose your own adventure. In fact, there's a life lesson in this. Sundays taste better when you choose your own toppings. It applies not just to the process, but also to the end result. It is one thing looking at someone else's photo, but when you've actually done it yourself, when you've carved your own path, and your photo today is so much better than the one from last month, there's a sense of pride that goes along with that. This is not, admittedly, as good of a photo. I have applied many of the toppings here to make this turn out better. This is not as good as some that I've seen on SFA Slack, but I don't mind because it's mine. And part of my secret sauce, my combination of ingredients, is I like doing multifocal length imaging. That is, I'm simultaneously getting images through a telescope, a wide angle, and a telephoto lens. And that allows me to do these composites that give me more of a sense of where I am in the grand scheme of things. So you can see the Orion Nebula, just above it, the Running Man Nebula. A little further, you see the Horsehead Nebula peering through. The Horsehead Nebula is focused right around one of the 3 primary stars of Orion's belt that we can see visually. Around that is the Barnard's Loop, and way off to the left is the Rosette Nebula, just trying to peek in. So there's just so much to explore in the night sky, and I really enjoy getting this perspective of where these tiny objects are in relation to the rest of the sky. All right, how are we doing a time check here? Okay, not too bad. So we've done all 4 categories. Now it's time, we will have the after dinner show. That's going to be a 10-minute slideshow. But first we need to do the dishes. I'm sorry, just a little bit of cleanup. So we started with this recipe box model. It doesn't really look like a recipe box anymore, but this isn't my goal is to give you an organized recipe box. My goal is to give you a tool that will tie these concepts together that you can use for astrophotography. It's going to be a little bit heavy. It might feel a little bit like science class just for a minute or two. First thing I'm going to do is get rid of the dividers. Next, the big and small labels down there, I think we can do better. Rather than just categorize it like that, I'm actually going to put a measure on here that's angular field of view. Now, you might be familiar with, you are familiar with angular field of view in our everyday speak. People often say they can see 180 degrees. That's seeing all the way from the left all the way to the right. Well, arc minutes is simply, there's 60 of them in each degree. So, in round numbers, our field of view, left to right, is right around 10,000 arc minutes. Let's bring in another visual aid that's really going to help us out here, and that is our smartphone. If you hold your smartphone at normal texting distance, the screen diagonal is around 1,000 arc minutes. So it gives you a little bit more perspective. You can see obviously the moon is quite a bit smaller, but even more impressive, those planets, they're about 1,000 times smaller than the diagonal of your smartphone at arm's length. So literally the planets are only as big as about 2 display pixels. That's what makes them so hard to image. They're really tiny. Let's do something with the bright and dim scale. Surface brightness is not a term that is often used in astronomy. It's quite often used in consumer electronics, but it does apply well here. Next time you buy either a tablet or a TV or a phone, if you read the specs on the display, it'll probably list surface brightness, and quite often, the surface brightness comes in right around 1,000 nits. So quite conveniently, this smartphone here is right at our 1,000 cross point. Now, if we compare our smartphone to the moon is brighter. The moon is down at around 4,000. So the moon is quite a bit brighter than our phone. Planets, the ones close to the sun, are brighter, like Venus. They get dimmer in terms of their surface as they get further away, like Saturn. Now, this is going to get a little busy. I'm going to add a few more items here. Remember, this is a reference. This is not something we're going to talk through tonight. You don't have to read all of these. But I just put on a whole bunch of other nebula and galaxies. So, for example, I'm going to come over here. I'm going to use my mouse. If we looked at the Lagoon Nebula right here, here's how I would use this graph. I've already used my telescope to image the moon, so I know how big the moon is. And my telescope is set up nicely for the moon. Well, the Lagoon Nebula and the moon are right around the same field of view, so if it works for the moon, it should work for the lagoon. So I already know roughly how big it should be. But what about exposure time? I used a millisecond for the moon. Moon is at around 4,000 nits. Lagoon is at 4 thousandths of a nit. I'll have to do some math. 4,000 divided by 4 thousandths, that's 1,000,000 times, which means I need 1,000,000 milliseconds to get the same exposure on the lagoon. 1,000,000 milliseconds is 1,000 seconds, or about 17 minutes. If I wanted to challenge myself even more, I might have wanted to image the North American Nebula. Now, it's quite a bit bigger, being at around 150 arc minutes rather than 30, so it's much bigger than the moon, so I can't use the same telescope most likely. I won't be able to capture the whole thing. And it's down at around 0.2 millinits. So that for that, I would need something like 3 hours of exposure time to get the same effect as I have a millisecond on the moon. This sheds a little bit of light, on why these the visual astronomers love us imaging people when we come out to the star parties, because they're doing their best to get perfectly dark adapted vision, using their red lights to find their way around, tripping in the dark, and then we come in with our laptops. We just like the attention, I guess. The other way I would use this, by the way, if I were at a star party in the city, I might aim more for the Ring Nebula, Dumbbell, Lagoon, Orion, because they're easy to see even from the city. The ones above the 1 millinit line, very hard to see from the city, unless you add a lot more toppings, that is, more processing and filters. So as you can imagine, very general rule, the further you get up to the right, the more challenging imaging becomes and the more toppings you need to get a satisfactory result. In fact, I'd even go a step further and say there's an imaginary line here where you have to shift your mentality. Below the line, you can take a picture. We're used to that. But above the line, you're creating an image. You're going to be taking many images over long periods of time. You're probably going to need a computer to control the camera and to control the telescope and so on and so on. So there's more involved. It's more of a technical work of art. Wrapping up here, I had mentioned this conference I was at a couple of years ago. It's the Advanced Imaging Conference. They have since cataloged all of their lectures online. There's a link there if you wanted to photograph it. Wonderful resource if you wanted to dive deep into any one of these concepts. We have our own version, the SFAA Observing Basics. There's a link. And if you are a member, our Slack channel is very active, especially the Astrophotography channel. If you wanted to share your photos, get comments on them, see what other people are doing. We even got into a philosophical conversation last week about the meaning of color. It was really fun. So there's just a lot of activity going on the Slack channel. And now, for the last 10 minutes, now comes the after dinner show. It's going to be comprised of 2 slideshows, a 6-minute show and a 3-minute show. I need to butt in and just the middle, but these are all works of art by all of the member photographers within the SFAA. there's some good stuff in there. We do have one more thing. What's missing? We've got the Milky Way, we've got galaxies and nebula, we've got planets and moon, and
The sun.
yes. Now, if bright is at the bottom and the sun is about 500,000 times brighter than the moon, we need a different chart. We're not going to talk about solar imaging other than to say, don't point your telescope at the sun, and even if you do, don't look through it with your remaining eye. However, there are people within SFAA who have really mastered that art. They have the right equipment and the right knowledge to do it safely. And the sun is not a smooth ball of gas like you might envision. It's actually an extremely dynamic, turbulent, violent surface. And there are several, you can follow them, SFA Slack, #solar. The sun is an exciting surface. The sun is not only giving us life, it's also actively trying to kill us. Every once in a while throwing out a burst of rage, and when that happens, you do not want to be in its way. So in this way, the solar imagers within our group are kind of our planetary defense team. If danger is coming our way, they know it first. In fact, that literally happened earlier this year, and the early warning that they gave us allowed us to experience a new kind of photography that is rarely possible here in California. Let's see how the story plays out. Special thanks to the Earth's magnetic field. You captured what would have baked us and turned it into a feast for our eyes. And of course, special thanks also to the astrophotographers who contributed to your imagery. Your works of technical art have captured our curiosity. Thank you. There, we have light. And Thanks also, Jerry, for composing the music for both of these pieces. Thank you. I know we can't really see, and we'll have more light in a minute. How many people here contributed? I know there are several who contributed images. Could you also stand up? I know I'm going to forget someone. Kit, Jerry, yeah, thank you. Okay, so if you have any questions, you'll just have to shout them out because I really can't see too much. Any questions tonight?
How far do you push exposure bracketing?
I don't have a hard limit there. My opinion, the Orion Nebula is one of the few that really needs it, because it's range from bright to dim. It covers such a wide range. Most of the other nebula, you just expose as long as you can. You're probably not going to saturate. Well, okay, maybe Lagoon, but for the most part, I don't really find too much need for bracketing. What's your experience?
I've never tried those.
Okay. Now, certainly if you want to get something bright like a planet and other objects in the same frame, then you'll need bracketing. Yeah. Oh, yes, you're right. Is it the moons with Saturn or Jupiter? Yes. Yeah. Question near the front.
Yeah, when you take a normal terrestrial picture, just a person, you have something out of focus, you call it bokeh.
Yes.
Usually, the shape of the aperture dictates the shape of that bokeh. When I take a picture of a star, what dictates how many points are coming off of the star? A telescope or
So there's two answers there. One is many telescopes, depending on the style of telescope, will have, let's say it'll hold the primary mirror up, and then there'll be spokes there. Though the number of spokes there directly correlates, I don't know if it's a one-to-one, but directly correlates, they're called diffraction spikes. Now, some people image with refractors, which ideally shouldn't have them, although even if you have like an f-stop with that, the circular fingers that come in, that'll produce some of that. But it is frequently common for an astrophotographer to intentionally add those because they really look pretty. Yeah. I don't know if anyone has different experience other than that with diffraction spikes. Okay?
Thank you.
Yeah. All right. Well, thank you. We do have some interesting lectures coming up. The very next one, Dr. Aparna, I'm not going to get her name right, Venkatasi. She is a professor here in San Francisco, astronomy professor. She will be talking about kind of who owns the night sky. So many of us are seeing a prominence of satellites that are cluttering our vision. And this is affecting people around the world, not just in photography, but also people who really revere the night sky. So she will be talking about that in October. And then, as we know, in November, our elections are coming up. And then in December, we're planning on more of a members' night. I mean, it's open to anyone, but it's really geared towards members, not only to hear from some of our own members about things that they are working on, but also to recap the elections, to meet the new board, try to collect as a group to figure out where we want to head this next year. So, come again. Thank you.